So now let's dive into creating tables with structured query language in SQLite. Now, if there is one class you stay awake for in this entire series, please make it be this one particular class, because one of the big things that you have to be thinking about with SQLite as a database system is how it deals with data types is, as they say, just slightly quirky. And this is something that you're going to have to keep in mind when you create tables in SQLite, and more importantly, as you start creating projects with Python or some other backend language and you start interacting with those tables, it is really easy to end up doing something stupid. So one of the great things about SQLite is that it's very easy to do something such as create a table. You do not have to create a primary key. You do not have to plug in a data type or anything like that. Basically, the SQL statement simply is create table, whatever the table name is, and then what columns you want there to be. So let's say we're creating a student table. We want the name, we want the age, and we want the size. That's it. Now you'll notice, again, if you're used to databases and you're used to SQLite, there are no data types assigned here. And the reason is in SQLite, you do not have to assign a data type. They basically figure you're smart enough to do this. And let's just hope you are, right? So you don't run into any problems. So then you might be sitting there thinking, well, I'm a little worried, right? I'm smart enough to know how dumb I can really be. So I want to assign data types, right? So here we're going to create a table and we're going to assign data types. So create table student2, so just a different table. We're going to say name is a text data type, comma age is an integer data type, so that is a whole number, comma size, that is also going to be a text data type. And so you're like, okay, there we go, right? I've assigned what the data type is, so even if I'm stupid in the future, I have protected myself. Well, the interesting thing about SQLite is that is not actually how it works. Basically, this is more a notation to yourself for if you do the .schema command, you can see what the data type is supposed to be. That doesn't mean SQLite gives a crap. You can literally put Bob into the age column, and that will be fine. So if you really do want to worry about the data type, because that's what you should do if this is going to be a real in-production project, that is where you do here create table, so student3, name is text, age is integer, size is text, and then we put strict at the end. By putting that strict in, that says this table should be used in strict mode, so if the incorrect data type is put into the column, then it will fail out. So now let's go into the SQLite shell to actually show you how this works, to really hammer home the concept of the issue with data types when you're dealing with SQLite. So we are in the terminal for my Mac operating system here, and so I'm going to SQLite 3 and then example.db. Right, so I've deleted the previous example database that we've used before, so this is a brand new one. Again, as soon as we call it, we create it. I hit enter. We can see I have that SQLite prompt right here, so we know we're in. I can do tables, and we can see that there are no tables in this particular database. So I'm going to create that student table, and we're not going to assign any data types to it. So we do create table student, and then we say name, age, and size. And we do a semicolon, right? So we're going to create a table named student. One column is going to be name, one column is going to be age, one column is going to be size. We close with the semicolon because you always need semicolon in SQL structured query language, and then we hit enter. Basically, as long as there's no problems, we don't get a response back, it'll be fine. If we do tables, just to show you, we can see we now have the student table there. So if I want to insert a record, so we're going to have a session on inserting records, a couple sessions from now, but I just want to show you how this works where we don't get an error. So if I want to insert, let's say, Bob into the age column, which could be a real problem, I can do insert into student, right? So insert into the table student, columns name, age, size, we close the parentheses, and then we say values, and then we do parentheses, and we do, let's say, Bob, 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 Bob. So for some reason, somebody just put in Bob across the board, because that's the kind of thing users do every once in a while. So insert into the student table, name column, age column, size column, values. We're going to put in Bob, Bob, and Bob for everything. I'm then going to hit enter, and you're going to see there was no error there, right? If I do select all from student, and then I hit the semicolon, we're then going to see Bob is there for name, Bob is there for age, and Bob is there for size, which is a bit of a problem for us. And so that's why we want to go in there, and now we want to assign a data type. We're like, oh, that's bad. We don't want that to happen. Let's assign a data type. So what we're going to do is create table student2, and then we're going to use the parentheses, and we're going to say name as text, comma, age as an integer, comma, and then we're going to say size as text again, and then we're going to do the semicolon, right? So create table student2, name as text, age as integer, comes around, and then size as text. So now we are assigning a data type, and then we're going to hit enter. We see no error, right? There's no error there, so we didn't run into any problems. So now we have our data types. But here's the thing, right? If we go and we basically do the same command we did before, we just modify it a little bit here. So we say insert into student2, right? So insert into the student2 table, name, age, size, values, Bob, Bob, and Bob. What do you think is going to happen this time? If we then hit enter, we're going to see that there is no error. So if we do select all from student2, semicolon, you're going to see that again you get Bob, Bob, and Bob. So although we assigned a data type, SQL's like, we're just going to do what we're going to do. So that's why we need to use the strict mode, right? And so basically with the strict mode, all we're going to do is we're going to come back here to the create table. And so just using the up arrow key to make this easy so I don't fat finger things the way that I do. And then basically what we're going to do is we're going to say create table student3 this time, name text, age integer, size text, and at the end, all we're going to do is we're going to simply put in the strict mode, if I can spell. There we go. Do make sure you can spell. Again, that's why I just use the up key, right? So now we're putting this strict word in at the end so that it actually basically abides by those data types. I'm then going to hit enter. We don't get any error or anything because there's no problems there. Then I'm just going to do that up thing again. So insert into student, and we're going to say 3. So this is a strict table. Insert into student 3, name, age, size, values, Bob, Bob, and Bob. Now when I hit enter, we are going to see, look at this, runtime error, cannot store a text value in integer column student3.age, blase, blase. So this is how creating tables and data types work in the real world of SQLite. It's one of those things that you are going to have to consider with your particular project. And a big thing with it too is simply the maintenance of the project past you. You have to think about what happens when your project is passed on to the next generation of geeks. And so although it does take, a couple of extra seconds to add in the data types in the strict mode, this could be very important going into the future. If somebody modifies, let's say your Python code, that back-end programming language code that's going to be interacting with the database, and they do something stupid, it is much better to have a hard fail where basically records do not get inserted and it fails so that they know there's a problem, rather what's called then a soft fail where it works but not quite how it's supposed to work, and you can run into some weird problems that way, right? So that is how you create a table, how you can create a table and basically say what the data types are supposed to be, and then how you can create a table in strict mode to enforce those data types. So when you deal with SQLite, there are going to be 5 data types that you can add when you create a table, and again, especially if you use strict mode to make sure you're getting the right data into your table. So we have the integer data type. And you will notice I say the full integer data type. So basically you can put in int. So again, if you've used other database systems, again, dealt with other programming languages with data types, sometimes you can say int, sometimes you can say integer. Again, that's a whole syntax thing for that particular language. In SQLite, what's interesting is you can use integer, and integer will store whole numbers. So you say integer as a data type, and you're good to go. Again, one of the weird things with SQLite is you can use int as a data type, and that will act as an alias for integer. But apparently, when you go and you take a look at the research, I haven't actually run into this problem. To be clear, I actually have not run into this issue, but theoretically it can be an issue. I've been informed. If you use int and you use strict mode, you can have some quirks. You can have some quirks. Sometimes strict mode doesn't deal with int as an integer the way it's supposed to. So one of those weird things out there. Then you have the real data type. Stores floating point numbers. So what floating point numbers are floats or decimal points. Basically any number with a decimal point in it is going to be a real data type. Now again, curiously enough, you can use float. If you say float when you're creating the table, that will be used as an alias for real, but also quirkiness might ensue. So use real. And I think that's the weird thing with SQLite. That's the thing about SQLite. SQLite is great because especially as a new coder, you can just sit there, you can do all this amazing stuff, and you don't have to worry about all that administrative crap you have to worry about on the other database systems. The issue that you run into is as your project gets larger, as more people are interacting with the project, and as the project starts dealing with some weird use cases you may not have thought about when you were designing it, you can start running into some, again, weird issues. You can have text. So text is just text. That is a string. Again, you can have the blob data type. So this stores binary data. We talk about binary data. That is files, PDFs, MP3s, whatever, image files. Don't. Can you? Yes. Again, unless you have a very specific use case, storing the blob data type is just generally not a great idea. And then you have numeric. A numeric stores numbers, including numbers with decimal points, floating points. This is one of those things where when you start getting really precise, you may have to decide between real and numeric. And what I mean by that is I had a buddy of mine who was creating a GPS application for race cars, right? So these race cars were zipping around at 200 miles an hour, and they had a GPS. They had a highly precise GPS that was constantly tracking where the car was, and they were running into this weird problem where the track, if you zoomed in for where the car was driving around the track, the car, it looked like the car was like just jittery all over the track for some reason. They couldn't figure out what the hell was going on. And don't quote me on this, but it was one of those things where it was like when they created their program, they used the data type of float. And so float had like a precision. When they talk about precision, it's how many decimal points out it goes. And float had like a precision out to like 8 decimal points. Well, the thing is, out to 8 decimal points was still something like a yard of difference. Right? So once it got past that, then the precision got wonky, and that's why they saw the car kind of jumping all over the road. As I recall, they switched it to decimal. Again, it might be the other way around. But anyways, I think they switched it to decimal, and like decimal had like a precision out to like 14 or something decimal points. And so basically, since it was able to be precise all the way out to 14 decimal points, then it showed the car doing what it was actually supposed to be doing. And that's the kind of weird stuff, again, you can get into with data types, especially when you're dealing with numbers, especially in the modern world as precision becomes more and more important, again, for things like GPSs and that type of deal. And so numeric is another data type that is very similar to the real data type. It's just kind of one of those things that's slightly different. if you start doing a project and you need like decimal points out to a significant degree and you're running into some weird issues, do some research between the real and numeric. You might find out that the data type that you're using is incorrect. For most of us out here, again, if we're looking at past 3 decimal points, past 5 decimal, whatever, right? Real should be good for you. So integer is going to be whole numbers. Real is going to be floats, basically decimal points. Text is going to be strings. Blob, you're not going to use. And numeric, you may or may not use, again, depending on your situation. So now let's talk about primary keys and row ID. Again, another amazing thing about SQLite, or a disaster waiting to happen. So most of the time when you're going to be creating tables with most database systems, you are going to have what is called a primary key. This is an absolute unique identifier for all records. So even if you plug in a record that has the exact same information, Bob, 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 and then Bob, 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 that primary key will be different so that your database will understand that there is a difference between those two and everything kind of doesn't go to hell. Now normally when you're creating primary keys, you may either have a very complex system for coming up with primary keys. So something like a driver's license number could be a primary key. Those should basically be globally unique. Or most of the time what we do is we simply do an auto increment. You start at 0, every new record that gets created, it increments up by 1. So record 1, record 2, record 3, record 4, record 5. So again, even if everything else is identical between a couple of records, that primary key is going to be different between the two. Now the thing is, when you auto increment, if you go back and you delete a record, it's not going to matter for the auto increment because you just keep incrementing from wherever you're currently at. Well, one of the things that makes SQLite very simple to use, very easy to use, is you don't have to worry about the primary key. Don't have to worry about the primary key. They're going to have a row ID column. So normally you don't see this. When we go over to the terminal, I'll show you this. So we're going to have a row ID, and basically as you create records, it's going to auto increment by 1 the row ID, and so you're going to go from 1 to 5 million or whatever else. But have I told you SQLite can be quirky? The issue with the row ID, and something you need to be thinking about, is if you delete a record, right? So 1, 2, 3, 4, 5, 6, 7, 8, all the way down to 5 million or whatever. And let's say you delete record 3, right? You delete record 3, and you delete record 20, and you delete these other records. One of the issues that you can run into is SQLite, based off its own decision-making processes, may reuse those numbers in the future. So basically, when you delete those records, that row ID essentially will go back into the pool so that SQLite may or may not use them in the future. Why that can be a problem is if you have something in your program or somewhere else that points to a specific row ID, you use that row ID as the identifier. If the original record gets deleted and then SQLite reuses that number for a record, in the future, anything pointing to that record number, you're going to have that new set of values in there that could be a complete and utter disaster. It could be a real issue there. So imagine you have a bill, right? Imagine you have an invoicing system. And so the invoicing system, you have 5 invoices and they're all related back to row ID of 3, right? So Bob, in Asheville, North Carolina. Now, for some reason, Bob has a heart attack, has a stroke. So you're no longer going to get money from out of Bob. So Bob gets deleted. You add Sue later. SQLite reuses row ID 3. And now all of a sudden, when Sue logs into her account, or if you look at Sue's account, you're now going to see these 5 invoices pointing at her. And as they say, all hell is going to break loose. So that is what we're talking about when we're talking about the difference between row ID and primary key. Again, if all you're doing is things like sensor values, if you already have something, let's say a timestamp, so you can just plug in a timestamp for a column, right? You already have a timestamp, you already have some other way that you're actually tracking the values, the records that are coming in, then the row ID may not functionally matter for you much. Again, if you have temperature values or sensor values coming in from 100 different sensors, you just need to dump them into a database so that you can process them rather quickly. The row ID is going to be fine. you're going to have no problems there. But again, if you start creating a system where you have user accounts and vendor accounts, inventory control systems, that kind of thing, you're going to run into some real issues if you decide to use the row ID versus actually curating a real primary key. So now let's go into the SQLite shell so I can show you how to access the row ID. Now we haven't done select statements. That's going to be in like the next class or something. So you're going to kind of have to go with me on this. I'm going to try to explain something here using things that you haven't learned yet. But don't worry, hopefully in the next couple of classes this will all kind of congeal together so you can understand really what's going on. So the first thing that we're going to do is we're going to go SQLite 3 and then we're going to go into example.db. So we still have a database that was created from a previous example, and that is what we're going to be using right now. So we're going to go in, and basically, once I'm in this database, as I've said, I have something from a previous example, so I can say schema. Again, for you, be like, oh, what's in this database? And then I can hit enter, and I can see, okay, from the previous example when we were creating tables, I have create table student, name, age, and size, student 2, name, text, data types, and then we have the strict mode at the end. So I can understand what tables are here. So what I want to do is I want to go to the student table, and I want to insert a couple of records, right? So I want to say insert into student, right? So these are different tables here. So I want the student table, and then I want to say name, age, and size, right? So those are the different columns. And then I want to say values, and then I want to say, I don't know, Timmy, 66, and small. Oops. Small. And then we do the semicolon. So insert into student, name, age, and size, values, Timmy, 66 and small. We hit enter, we don't get an error because everything worked out fine. I can just do up again. So if I want to add some multiple values here, so I can do Sue, I can do 16, and I can do medium. Right, hit enter. Again, we don't get any errors because everything worked out fine. So now if I do what's called a select all statement. So when we do a select all statement, that's going to be all the columns. Again, got to put some parentheses because we're using SQLite here. So I'm going to say select, this is all, from student. Student, right? Semicolon. So select all columns, and so what you'll see is name, age, and size from student. So I hit enter. And that's what we're going to get, right? From our previous example, we have Bob, Bob, and Bob, right? I was showing you how data types don't really work in SQLite unless you use the strict mode. Here we have Timmy, 66 and small, and we have Sue, 16 and medium. That's how it's supposed to look like. But you'll notice here is there's no row ID. Even though we said select all, we didn't actually get all the columns. You actually have to ask for the row ID. So what we can do here is, again, I can just do the up arrow, and then I can say row ID, name, age, size. And again, if you don't fully understand that, don't worry. We're actually going to do select statements in another session. So we're going to say select the row ID column, the name column, the age column, and the size column from student. And we're going to hit enter. And now we see 1, Bob, 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 2, Timmy, 66 small, 3, Sue, 16 medium. And so that's how we're actually able to get those row IDs. So these are unique numbers, right? And so this will always be unique, right? That number will never be reused at the same time. You will never have 2 row IDs of 3. Again, that's an important thing to understand. Again, you may have a record that was 3, you delete that record, and a new record may reuse 3. So when you're designing your system, that's just a thing to keep in mind, but that's basically how you're able to access the row IDs. So now let's talk about creating an auto-incrementing primary key. Right? So again, think about if you're going to have these records and you want an absolutely unique identifier that will never be reused by anything else, that's why you're going to be wanting a primary key. And again, most of the time it is going to be auto-incrementing. So we're going to stay here, and I'm just going to show you this from the notes so you don't have to suffer through me fat fingering things. Basically what you're going to do is when you create your table, the first column you should create will be ID. So we have ID here, This can be whatever you want it to be. Again, it can be people ID, vendor ID. I don't know. It can be whatever you want. Again, have ID in there so you know what it is. Then we're going to say integer. Again, full integer, right? Then we're going to say primary key. Those are actually two different words. And then we're going to say auto increment. So this is going to be the primary key. We're going to auto increment every time created goes up by 1. Then we have a column for name, a column for age, and a column for size. If you insert into then student 4, so we're creating table student 4, name, age, size, Bob 22 and large, insert into student 4, Sue 20 and small, so we're inserting those in. Now if you do select all from student 4, what you're going to see now is when you just select all, you get an ID column of 1 and 2, you get a name of Bob and Sue, an age of 22 and 20, and a size of large and small. So now you have this auto-incrementing ID column. So basically, again, you have that unique identifier that will not get reused in the future. It is important to understand, though, you still actually do have a row ID column that you may or may not want to use. So if you do select row ID, comma ID, comma name, comma age, comma size from student. So you're asking for all of these columns. You're actually asking for requesting them. What you'll see is there's an ID 1 and 2. That's the first column. And then an ID 1 and 2. That's the second column. That's your primary key. And then name, and then age, and then size. Right? So even when you create a primary key, that row ID is going to continue to exist. Again, the question about whether or not you need that primary key really comes down to the system that you're going to be designing and how much faith you have in the next generation of technicians that are going to be dealing with whatever it is that you're creating. So that's how you can create an auto-incrementing primary key. And again, anytime that record number is really going to matter. Invoicing systems, again, any kind of customer relationship management systems, work order systems, any of that type of stuff, put in a primary key. This could turn into a bloody disaster if something in the future goes wrong if you don't use the primary key. So there you go. Now you know how to create a table. You know the easy way to create a table. You know the way to create a table with a couple of notations so people know what you're expecting in the table, and you know how to create a table in strict mode so data types apply. Again, we talked about these data types. Integers, real, and text is what you're really going to care about. Again, you can refer to integer by int, but it might end up being quirky. You can refer to real as a float, but it might end up being quirky. And when you're dealing with numbers, again, really long, complex numbers, whether you use real or whether you use numeric, that's going to be something for you to do the research to figure out. Again, we talked about the primary keys and the row ID. The row ID gives you a unique identifier for every record, but again, quirkiness can happen. If you delete a record, that row ID might get reused. So that's why you might want to use a primary key. The good thing about the primary key is even if you delete records, that record number will never be reused, so you won't run into quirkiness. So that is the idea behind tables, strict mode, data types, and primary keys versus row IDs.